Hello students, in this video we'll discuss about the lexical analyzer generator called LEX. So in the previous video we have discussed about recognition of tokens. So how these are going to be implemented. So the tokens, we are just specifying the regular expressions, but how we have to convert into a program. Because we have discussed, the compiler is a simple program, not simple. It's a program, someone has tried the code for it. So means they have tried to code for lexical analyzer, syntax analyzer, semantic analyzer, like for every phase. So if you want to write the code for a phase, that's your wish, you can write it, or you can use the tools to develop that phase. So there are two ways to implement the phases. So it can be the implementation of any phase. So even the lexical analysis also can be done in two ways. So by writing our own handwritten code, like Dennis Ritchie wrote the code for each and every phrase in his own. That time there were no tools available. So now if you want to develop a new compiler, there are so many tools available in the market for lexical analysis, syntax analysis, semantic analysis, for all. So for example, assume that you are developing a compiler for some XYZ language. And the first phase is lexical analysis. And if you want to write the code for the lexical analysis, first you have to decide what are the tokens in it. Then when these tokens are going to be identified, means when lexemes. So how these lexemes, you have to write the regular expressions and convert the regular expression to finite data metas. Then convert the finite data meta to transition tables. So these tables you can represent in 3D arrays. Then you can write a C program on it to represent the or recognize the tokens. So when you are writing in your own, first step is specify what are the tokens, identifier, constants, reserved words. When should be treated as mapped into identifier, in what are the cases of lexemes, and when you can say that it's a lexeme, which pattern it has to satisfy. Now we have to convert this regular expression to finite data meta, because you cannot write the code directly on regular expression, right? Then convert into machines. Machine can be converted into tables, and tables can be represented as arrays. Then you can write the program. And of course it is a difficult and complicated and time taking process. Instead of that, you can use the tools. For example, if you are writing the code for lexical analysis in C language, right? You write the code for the syntax analysis, semantic analysis, remaining 6 phases. But for the lexical analysis part, you can use the tool called LEX. So and write whatever the rules you want here and give it to LEX. The LEX will convert your code into the language code where you are developing your own compiler. For example, C or Java. For C, you are going to use LEX in Linux operating system. In Windows, you are going to use FLEX. For Java, we are going to use JLEX. As Java is machine independent, you can use the same JLEX for all the programming languages. But C is not like that. So lexical analyzer we can generate automatically by giving the patterns to the generator and compiling those patterns into code that functions as a lexical analyzer in a particular language where you are writing the code. And what is the advantage of doing like that? See, once you use the handwritten code and you are here and you want to change something, again you have to start from the tokens. It is difficult. But in the lexical analysis or lex generator, just go to the input file and change and compile again it. No need to write any representations and conversions. Automatically that will be changed. So it is easy to modify because we have to write the only affected patterns, not the entire program. But here you have to change the complete program. So in that way it is also speed up the process of lexical analyzer. Here it is a very slow process, but it is going to speed up. So then how we have to do it, right? So for example, if you are developing a LEX tool, right? Lexical analyzer, not LEX tool, lexical analyzer. So you have to use what? LEX. So it is also called as flex if it is used in the Windows operating system. Then see, simple, like for example, if you want to execute some program on Windows operating system, then first you have to write the code in C language, then use the C compiler, then convert into, after all the process, c.exe file. So same way, now while you are executing the C program, our targeting is Windows operating system. But assume that we are writing a first Java compiler program, as in that Java 1.1, where it's been written in C. For the Java 1.1 compiler, the Java compiler was written in C language, as I told you. So you have to write the lexical analysis for Java, syntax analysis for Java, semantic analysis for Java, like you have to write all the phases. So you can write whatever, but for this lexical analysis, you can use a tool. You don't need to write the code. For what? The lexical analysis phase. Remaining, you write the code. How to do it? First, like our targeting machine is .c, right? Then you open a legs file, right? Lex input file, and it is going to have extension called lex. Like C file is having .c, lex. Then you write all the regular expressions and patterns, everything. Okay. Then you compile by using lex tool, like C compiler, lex compiler. Then automatically it will generate the lex.yy.c. So the .c extension can be used here. That's it. Like if you want to execute in the machine, you are writing the machine understandable code in .c file, compiling with the compiler and executing in machine. Same way, here our targeting machine is .c file, and you have to write the input in lex tool, give the input in lex tool, compile with the lex compiler, and automatically the .c file will be generated that we can use it wherever the C file. Then this input file, okay, whatever the input file, is mainly divided into three parts. One is definition part, rules part, and auxiliary routine part. And all these parts are separated with the double percentage sign, like this. So three parts: definitions, like what is letter, what is digit, define letter, define, right, rules. What are the rules for identifier? What are the rules for numbers? Routines. If identify rule is satisfied, what is the routine we have to execute? So this is how it is going to be append in the lexical file. So in it, first in the declaration section, so it have to declare the variables what we are going to use, identifiers, the name of the token, and regular expression. Like for example, see, letter. Define what is the letter, capital A to capital Z, small a to small z, like that. Definition, like you can say that digit. So what does it mean by digit? For example, if it is octal number, you can write 0 to 7, your wish. And at the end it has to be separated with the double percentile sign. Then same way in the rule section, once the definition section, if you have defined something, then write the rules based on the definitions. Like rule 1, identifier. What is the rule? Letter followed by letter or digit whole star. So where is the letter? It we have defined in the definition section. What is digit? Defined in the definition section. Then if this is happened, what we have to do? So update symbol table with the ID. Right. So here I'm calling a function. When this pattern is satisfied, we have to call a function. And what it is function is going to have? What is a code that we are going to specify in the auxiliary routine? So this section contains the functions which are going to be loaded with the lexical analyzer, or some procedures which are going to be executed when an action is performed, right? So these are the that are going to be placed in auxiliary routine. So mainly YY-LEX, YY-wrap are the predefined procedures of LEX. So what is the use of it? So that we'll discuss. So now while you are creating a lexical analyzer, as we have told, so first you have to open a LEX file, the input file, which is going to have the three sections, and define it, rules, routines. Then the file name is .l. Compiler, it will give you lex.yy.c. So if you give lex.yy.c to the C compiler in Linux, it will generate a.out because lex is for Linux, flex is for Windows. Now this a.out is nothing but the lexical analyzer. Now give some input string, like for the a.out, a plus b star c, then it will give you id operator, id operator, id, like that it will give you the output. So this is how the lexical analyzer is going to be generated. So while you are writing your own compiler, the all tokens code you have to specify here and compile it with the lexical compiler. So this is how it is going to be generated. So now not only this, for example, if you go for Windows, as I told you, in place of lex, you can use what? flex. And if you are executing the Java, in place of flex, what you can use? jlex. Like that, for every language which is available in the market, appropriate lex is also available. So this is the end of the first unit. So in the next video, we are going to discuss about the second unit, that is the role of parser.